Hello and welcome back to part 2 of part 2. This is source code and database demonstration. In this section, what we're going to introduce you to is how is this data model actually delivered to you? What does it look like in being delivered to you? And then how does it become, or how does it go into the database? And that's being by CTL. So they are the two separate things we're going to demonstrate to you now. How does the data model get delivered to you? And then what does it look like in the database? Now to do this, we're just going to have to go across to SQL Explorer. My mistake, I wanted to start with the workbook, the definition workbook. So we have BI4ALL models, all 3101. So the current release on today, the 11th of February 2014, is 3101, 846 tables, something like that. Okay, and this is what you get. You get a spreadsheet. That's what you get. A friend of mine said to me, you know, I can't believe that you sell a spreadsheet with a data model in it for a whole lot of money. That's pretty cool. But this is how it comes. You get a spreadsheet and it comes with data models inside it, and that's pretty cool. And I'll scroll down just to show you. This is how long it is. You can see it is 33,249 lines long, this spreadsheet. Okay, it is a very significant spreadsheet. Okay. I'll talk about some of the features of this spreadsheet. The first row is number of languages. We deliver the data model in just one language called English. Okay. If you want the data model in another language, you're going to have to create that language yourself. If you want to overlay another model over the top of our model, you're going to have to do that yourself. So we deliver it in one language, and that is English. But you can have up to 10. You can put 10 in that number because we have 10 languages. Now, given that we have 10 languages, we have to have target directories. So the target directory for what's coming out of the generation is temp BI4ALL, and we called it target 01 through lack of imagination. And of course, if we go off to the right, we will see we have 10 target language directories. And that is, it will generate SQL, data definition language, into the target directories that you give it. The next row type we have is view definitions and short descriptions. Okay, so VM party, we tell it what submodel it is, we give it a view number so that we can look up these view numbers easily. And you see it says this table records all the parties. A party can be a person, company, or household. That's what it says. Next one down says this table records the parties who are known to be people. Next table says this table records the parties who are known to be sales representatives. And we have 846 of these. Okay, so when I went through and said, you know, this does this, this does that, contract end reason code, you can see this table records the reason code for the end of a contract. Okay, so we do have view descriptions for each view built into this definition of the data model. Okay, now where we have view description language, we can give up to 10 descriptions of the view in up to 10 languages if we like. Okay, so if you are one of my customers had 5 languages, they needed to support reports in 5 languages, and so you know this would have been handy. We didn't have this at the time, but giving the data model to the business analysts in the 5 different countries in the 5 different languages, that would have been handy. And this is kind of where this idea comes from. So what we'll do is we'll scroll down. Obviously you can see, you know, added for 3001. So added for 3002. Okay, so this kind of thing you can see what was added. And then here we're on the media model. Okay, so we're yet to talk about media models. So, but you can see media ad class code. You can see the classification code for an ad. So we will just keep scrolling down. So you can see, yes, we do indeed have all these view definition, short description rows. And you can see the row numbers going up. Okay, so ended added for 3001. So this is 927 rows we're down to now for the short descriptions. And then we have view descriptions, view definitions, long descriptions in the spreadsheet. Okay, and VM party. And it probably won't surprise you to realize that we've used the short description name exactly in the long description field. So if anyone who's a user if you're a user or reseller of this kind of thing and you want longer descriptions, have at it. Type your longer descriptions in there as much as you like. And of course, again, up to 10 languages for the long descriptions, head over the top of the view name. Okay. So we'll scroll down here again. You'll see the number of columns, number of rows increase, and here's one. Tell bill payment error transaction. Here you can see that we've put in a much longer description. Okay, so just to show you an example of, we do have long descriptions in here. Okay. So we keep scrolling down and we come to view column definitions. Okay, and we're already at 1,853. So we have defined the descriptions of the views and the row numbers above, and we've given each view a long and short description in the spreadsheet above. Okay, so now we're coming down to the individual table, what we would call a table or a row type. And so we have the row type, V column definition, VCD. We have a type, and I'll go through each of the columns. So the type, at the beginning of each table, you are required to put the letter B for begin table, and that's just because of lazy programming. So when we see B, we know we've seen a new table. Where we're just moving or just specifying a mapping, the letter M. So this is a mapping between a real underlying table and column to a view. When we get to F, this is a from clause, and we name the from clause for the table. So TD 0100 is the from clause. So it's going to say from TD 0100. Okay. And then the where clause, W, is going to tell us where it's from. And you can see that in this one, it's saying the party type integer has to be 1, so it has to be a person. The level column has to be detail, and the character 104 has to be yes, or the primary key is 0 to expose the 0 row. Okay, so that's what's necessary to be true for this to be displayed as a person. Okay, so you can obviously see that this is going to be generated into SQL. You have the opportunity to name the table owner, and then you have the table name itself, TD100. So TD100 is the 0100 is the table for parties. Then you have the physical column name in the table. So in the table TD100, you'll have the physical column PKTD0100. You have varchar 255. We have 22 varchars. We have some dates. We have some integers. Those kind of things. We have some char 01s. And then we have a a thing called dimchar key field, more on that later. Level column, the row deleted from source indicator, the batch number that it was processed through, the file cycle number that it was processed through, the view number that it has, the audit timestamp, and the source system number. So on every single dimension table, you will see these fields: dimchar key field, level column, row del from source, batch number, file cycle number, view number, audit timestamp, source system number. You will see that on every table. And these are what we call the audit fields. And they're necessary to give us a chance that if our ETL subsystem has a serious problem, at least we've got the batch number, the file cycle number, and the audit timestamp on the rows that were affected. We keep the view number to tell us the number of the view to expose the data to give transportability between physical tables. And we keep the source system number because we like it. It's a very handy field to have about. We keep the row deleted from source indicator so that when we know a row was deleted from a source system, we can mark it as deleted in the warehouse, but not actually delete it. So we can see which rows are being deleted and recreated, etc. So that's the physical table. And then we have a view owner name, and then the actual view that's going to be used, language 1. Remembering that if we go over here to the right, we see that there's many view names over there, and we can have up to 10 languages for view. So this first table is VM person, and so the view name is VM person, you can see that. And then the column number, let's just go here, one to the left for a minute, and then the column name is given. So prefix, first name, second name, third name, surname, concat name, address to name, and this is what you saw in the piece of SQL which was the view in the prior presentation. Okay, and this gets generated like this: web address, tax number, government identifier, phone home, phone work, birth date, current flag, employee flag, these sorts of things. Vendor flag, party type, etc. So you have all these different fields in the view. And then you have a short and long description for every field in every view. Now again, it will come as no surprise to you that we have the same short and long description, right? But if you adopt this data model, then you can put in the short and long descriptions that you want. This can be put into tools like help text and things like that. It goes into our dictionary and can be reported on through our dictionary, right? Now, one great thing about looking at this kind of data model is we can drill in Excel on this. Okay, so we could say this is VM person, and I'm looking at that. Okay, that's interesting. I can see what's in VM person, but I want to look at another table. Normally you have to navigate around your database manager and things like that. And of course, until you build this into a database, it doesn't exist in a database. It's just a spreadsheet. So I can go here and say, I want to look at VF account close transaction, and just drill on it. And you can see that these fields turn blue, and I've drilled on VF account close transaction, which is in the table TF0101, PKTF0101. You can see the meaningless field names there. You can see money and etc. in there. And you can see the view name. And you can see this is what we said was on the view on the prior presentation. And you can see PK account close transaction. You can see the dimension tables there. Okay, you can see all this. This is defining the data model. So when you're using it, when you are building the data model, what you do is you take pieces of the real data model and you copy them to your new data model, and you have the superset of BI4ALL in the spreadsheet delivered to you, and then you have these are the tables that we're going to use out of BI4ALL, and these are the additions we're going to make to them. Now again, we have for tables, we have table number and view number. So all fact tables are allocated a table number and a view number. There's two different things. We then have, is the row deleted from source indicator? We have partitioning columns, which were necessary for SQL Server 2005. We again have batch number, file cycle number, view number, audit timestamp, and source system number. So on every fact table, you're going to find a primary key, a set of detailed keys, transaction numbers, set of data, small set of data, and then partition number, partition columns. Batch number, file cycle number, view number, audit timestamps, source system number. You're going to find that on every fact table. Okay? And this is how we manage it. Delivery transaction. Primary key, delivery date, delivery minute, sub-campaign. Delivery unit amount, delivery costs amount, delivery taxes, delivery units, a number of deliveries, return units, number of returns, returned indicator, delivery transaction return flag, return period expired indicator, return probability percent. So for every delivery, we say, has the return expired flag and what's the percentage probability of the return? Okay, that's the kind of things we do. So that's delivery transactions, and you can go through those and look at those. Now this is how the data model comes to you. Then of course the next question is, okay, but data models have joins and tables are joined to each other. So how do we define the joins? And this is our data model joins spreadsheet. And yes, this is true. Every single join in here will generate a referential integrity constraint to tell you that these two tables are joined. So this is actually the real joins. We're not just kidding you here. You can see there's 5,267 lines in this joins table. So you can define the joins between tables. And obviously you have left table, left column, right table, right field. Okay, right column. So this is VF account DIMS association, is having these columns associated with these fields. Okay, and this generates actual constraint definitions. Okay, so we will pop over to those in a minute and prove to you that this happens. So I don't want to go into this too much in terms of joins. I mean, we can put filter on here, auto filter, and we can say VF account transactions, and we can look at the joins, and we can say AP invoice line, we can look at the joins. We have segment frequency, we can look at the joins. So we can look at these joins inside a spreadsheet like this, just using drills. And this is where I like to use the older versions of Office, because I prefer the older drills. That's what that's about. So we can see any table, what it's joined to, and we can confirm that the join has been created through the joins spreadsheet. Okay? Now just to convince you that this did run and it did put the constraints where it says it put the constraints, here's temp BI4ALL constraints as the output definition, the target file. So it's got there as a target file. And if we go to BI4ALL models and we go back up to the top, across, we'll see temp BI4ALL target. Okay, so if we go over there, target, we'll see data model views, table documentation, data model documentation, table create constraints. We'll see some tables created in here, and these are created all some time ago, 2011, which was our last major upgrade for our data models. So we open up TextPad, we find data model views, and we find that this was run on 26th of the 12th, 2011 at a certain version of CTL 3100, and we see drop view statements, and that's fine. It's going to drop views, 800 of them, and we see a create view VM person, and just like the mapping said, it's TD0100. We can see the varchars there. We can see how it's going to be presented. We can see TD0100. We can see party type int, level column, chart field. Then we can see sales rep. And I'll go down a little bit to find something different. So VM blacklist type code goes to the table TD0003. It's giving you blacklist type, code, a short description, long description, help description, date from, date to, and the audit fields, where the code name is VM blacklist type. Okay, so what this has done is take the SQL, or take the spreadsheet, and we'll go down to a fact table. Here's a fact table, web wishlist items. So this is PK web wishlist item, the dimension table links for that, the data for that, the audit fields for that, from TF0104, where the table number is 13712. Now if you look over here, you see this is 34,830 lines. Okay, 34,832 lines of generated SQL code to create the data model as views is what's in here, for 1 to 2,000 euros per month. Okay, so when we say we've tried to make this available to anybody who wants it, if you can't pay, depending on your company size, 1 to 2,000 euros a month for a license for this, we would say you don't want it. Okay, rather than having any other objection. These data models, if you want to buy them, if you're a very big company and you want to buy them, of course there's a price tag associated. But if you're a small company and you say, yeah, well, I'd like a data model like that, but I can't afford it, we don't believe that any company can't afford 1,000 euros per month. We're not going to buy that. So that's what you get as the base model. Now in terms of constraints, you can see that alter party, add constraint, PK VM party, primary key, PK VM party. So you can see that we're adding constraints to the party tables. Then once you get down a little bit, you can see something like alter VF run log plan add constraint, PK VF FT run log plan primary key this. So it's linking the oh, that's just adding the primary key, sorry. Here's the add constraint. So this is, oh, these are still more primary keys. Okay, this is just adding the primary key constraints, sorry. There should have been, there is another file, there should be, which adds all the constraints linking the tables. But I've rerun this, and so I've just got the constraints for the tables themselves. To show that there is a create table, which is again also generated. And this was also on the same day, back in 2011. Create tables. And you can see it creates the tables with these audit fields at the front, physically. And then you have char 01 through char 20, obviously defined as char 1. Integer 01 through integer 20, defined as that. Money 01 through money 20, defined as that. Decimal 01 through decimal 10, 3810. Floats, dates, timestamps, varchar 255s, and some dimension table aggregate keys, which you guys won't use, right? So it did generate this create table statement. Yep. TD's 0002, similar thing. only here they're all char 1s because this is our indicator table. So this is proving that it generated constraints, proving that it generated views. Okay. Now I've been talking about generating views and adding constraints, but we all know you can't add a constraint to a view. Okay. So how do we get something that we can add a constraint to? How do we get a physical table? So what we've done with CTL is we've said you can maintain the data model in one database, and it must be views and all the rest of it, small number of tables with views over the top, and I'll show you the actual database in a minute. But we can't put constraints between them, so we can't draw diagrams with diagramming tools if that's what we want to do. And we can't really get a feel for the connections between these things, apart from just trusting that they're connected. So many people ask us, well, we want a documentation database and we want to import it into our ER tool, and we want to be able to build our own little data models on certain areas, pictures and diagrams, etc. So we finally said yes to that and said, okay, we'll create a documentation database. And the documentation database will be the database appended with the letter D for documentation. And we will be able to create tables in the documentation database by selecting from the real data model database where 1 equals 2 to say we don't want any rows, but use the create table insert into modeling on the other table. So this is how it's done for SQL Server. It selects star into documentation database because it ends in a D, VM party, from real database, which doesn't end in a D, VM party, which is a view. Okay. So now we'll just go over to the SQL Server Explorer. And here we are in SQL Server Explorer. We can see it's called IBI4ALL is the name of the machine. And we're using still SQL Server 2008 R2. And we see the development database, BI4ALL 3000. Okay. We see in tables only 105 tables, and most of them are these control tables. So the control tables don't count. That's 83 items. They don't count. They're just there for making sure that the database hangs together. The tables that we're using is 21 items. Okay, so we have here to here 11 dimension tables, physical tables, and 9 physical fact tables, and 1 work table. So if we want to look at what's on one of these tables, we go down to here and we open it up. We look at columns, and we can see the columns. Okay, nothing stunning about these. The primary key, the level column, the dim chart key field, the date from, date to, current flag, table number, row deleted from source, batch number, file cycle number, view number, audit timestamp, and source system number, and then the actual data for the table with meaningless names. And this one's got 50 varchars on it. Okay, and you can of course pause this and look through it. So this table gets put into it very, very, very many different tables. Same with O2. Same with TD0005 is our date table. So you see it actually has field names along the naming standard of dates. 6 is our hour-minute table, things like that. Then TF0001 is our type 1 association table, so it has an association key and up to 30 association keys in it. TF002, only has 2 associations in it. Okay, so when we need to associate 3 or more things, we need to use association table 1, and where we need to only associate 2 things, we can use association table 2. And we've stuck some fields in there so that we can put some extra data in there. Then the fact tables, and you see we have table number, we have the primary key, the table number, and all the things. And notice primary key is a primary key shown by Microsoft, but these are not related to anything. So we have lots of fields in the fact tables, lots of fields. Okay. And then TF101, lots of fields in here too. Okay. So those are the tables in this documentation in this real database. Yeah. What about views? Well, we go into here and we click on views. We'll see there's 848 views in here, a couple of spares. So 848 views in here. Okay, count closed transaction. You can scroll through and see them all. And we'll go through all the table names in a minute for the other subject areas. So here's a count closed transaction, physically existing in the database as prototype data model. Okay. So I'm showing you this so you can be absolutely sure that what you saw in the spreadsheet gets into the database via our tool called CTL, right? And you maintain the data model in the spreadsheet and push it into the database. And in our sample data warehouse, you actually have CTL and you have views and tables and things like that where you can execute CTL and you can see what it generates. What you don't have in the sample database, of course, is you don't have the full data model because that's our intellectual property. Yeah. So here you see all the different fields: invoice header, invoice lines, etc., that we talked about earlier. So here's invoice line. You can see when we click on here the columns in invoice line. Okay. So invoice number, line number, taxes, line short descriptions, order date, scheduled delivery, scheduled payment, the link to the header, and the audit fields. And if you want anything else on invoice line, then you put it in, right, as you map it through from the source system. So we said that it can create tables and then apply constraints. Well, here is the demonstration database, okay, the documentation database. When we click on views here, there are no views. You say, oh, there's no views. Click on here. We haven't got the control tables in here because we don't need them. These are tables. And if we click on here and click on account transaction close, we'll see something very different. We'll see that the primary key is identified and all the constraints are identified. Okay, the constraint code has actually run against this database and been identified as a constraint. And then the transaction amount, unit amounts, timestamp, application system reference number, short description, long description, table number, and the other audit fields. Okay, so you've got this, these constraints have been set, yeah? And so all through this documentation database, you can see this has been done. And you can see that there are 847 tables in here. I'm not quite sure what the last one is. Yeah, doesn't count. So you can see there are 847 tables in here in the documentation database. So you can be sure and certain that what we were talking about on the slides and what we were talking about in the spreadsheet gets generated through to SQL Server for a start. Now, if we want to start doing some other databases, you generate them through to use the database language of the database that you want to generate the physical tables that you want, or indeed you can generate the tables any way you like. Then you can put the views over the top of those tables, and that's how this works. Okay, so we would suggest in prototyping, we quite like SQL Server to prototype in. So in prototyping you could use SQL Server, but of course you can use anything. We're probably a little bit weaker on supporting some of the other databases in terms of database languages, and so we would have to look into exactly, if somebody says we're going to buy BI4ALL and we're going to buy it on Oracle, then we'll make sure that we ensure that everything you need on Oracle gets done. Okay, right now it's mostly being done on SQL Server because that's what we use. That's what a number of our resellers use. Okay, so this is showing you what's inside the database. Now let's just go through some things like the segmentation engine. This is our segment frequency. We have the primary key. So segment frequency, we have the day, the customer, the segment type, the segmentation run log, then the campaign that the customer came in from and the customer dimensions association, and the account, demographic, geography, map references, sales for the rep, the sales rep, company reporting structure, segmentation version, where we can have many versions of the segmentation engine. And then we have the indicator, the frequency segment indicator 1 to 64. Okay, then the audit fields. And then we have monetary value. Same sort of thing, all the keys, current flag, versions, and then monetary amount, segments 0 through 64. So this allows you to calculate the actual number of dollars, pounds, money, whatever, for a customer for a period through the segmentation engine. Okay, that's what's in there. So this is our demonstration of the actual database sitting inside actual SQL Server, live and running. You can test it out through our standard demonstration process. Our standard demonstration database creates tables, creates views, all on SQL Server. You can test it out, but you can be sure there's 846 tables in here. Okay, we're not telling any lies. We could count the number of columns. I guess that the spreadsheet, if we just go back to the spreadsheet, I guess that when we scroll down in the spreadsheet, and we need to go down to the drillable area again. When we scroll down to the spreadsheet and we say all, and we go down here and we say there's 33,248 lines in the spreadsheet, I'm pretty sure now that you've seen the database as well, and the tables in the database, etc., that you're not going to question that there is actually 33,248 lines in the spreadsheet, that we've made that up in some way. Okay, so this is what you get when you get BI4ALL, right? And we can give you samples of tables, but of course we can't give you the whole data model because then you won't pay us. But for example, if you want to get started and you want a project and we can do the mapping for you, we can do the build for you. To get started, it is between 12,000 and 24,000 euros to license the models to get started, because we won't build the models without you licensing them. You license them up front. Standard vendor license your software when you want to start using it. Okay, so that's what the data models look like. Now we'll just go back to our presentation, and that was our source code and database demonstration just for the base BI4ALL, and I took you through some tables. Okay, and what we're going to say now is this is the end of part 2 if you've got no non-disclosure agreement with us, and we will know whether you have that or not. The next part is only for people where you signed a non-disclosure agreement and we're satisfied that you're going to keep that. We have something very interesting to tell you more about how we handle the archiving of data within the database, but we only tell people who are very serious about buying BI4ALL and who have a non-disclosure agreement in place. So we'll be back with part 3 of part 2 if you have a non-disclosure agreement. If you don't have that non-disclosure agreement, then we'll be back with part 3 of this presentation. So thank you very much.